All right, welcome back. We're here in part 2 with Oram. We could have many more parts. In fact, that kind of reminds me, at the beginning, he was going down the path of mold, like going into mold conversations in the beginning of part 1. Look, I know that's a huge topic for a lot of people, not just Lyme people, so maybe what we'll do is not today, but go into that, because obviously he's a wealth of information on that as well. So I did cut him off, and some people might have been excited about that, but we got to start somewhere. We got to start with EMF.
If you go to my website, createhealthyhomes.com, and you click on Tips for a Healthy Home, there's a section that I wrote there years ago on how to avoid mold. And also,
and your website in general is just a wealth of information, and you blog regularly, so yeah. So those are great sources.
I wish I could have the time to blog, but I wish I had the time to keep the website as current as I'd like it to be, but there is a lot of information. Mostly
hey man,
articles.
Don't we all? Go to my website, it's pathetic. So the last thing I'll say about this is this section, what I want to do today is, with this piece, is if you haven't watched the first piece, that's the science, that's a little bit of the backstory, what's actually happening. We've got details under the show notes that can send you to some of the scientific studies, some of his blog, which is going to have more information if you're trying to get your family to shut down the Wi-Fi so you can heal, so ways that you can talk to them. What I want to do now is go into solutions for both the home, for cell phones, for the devices, talk about some of the pendants. We talked about some of this specifically, but some of the things that help mitigate EMFs, things that you can do that probably everybody needs. So, and then we'll do live demo, and who knows where this is going to go. We'll do a little live demo on, because I've always been curious. You know, they say when cell phones were passed from a civilian technology to or the other way around, from military to a civilian technology, that one of the conditions that the government set up was, hey, we have a few conditions. We're not just going to give you this technology. It needs to be able to be triangulatable, meaning if anyone with a cell phone needs to be able to be triangulated between cell towers. Obviously, we've gone way beyond that into GPS now. And then the other piece was that they could turn it on. As long as a battery was attached to your phone, it didn't matter if it's on or off or airplane mode, doesn't matter what, that they can get in, turn your microphone on, and hear what's going on in the room and that cell phone is in. Yes, the world does not work the way that we were told. So I remember when you came over that we actually measured, I was wondering, well, if the phone is off, if it's in airplane mode, is it really safe? What's kind of happening with it? So maybe we can measure some of that stuff at some point. At the very end, I definitely want to get into, he's got devices. Some of these are pretty expensive. Some of them are kind of outside of the scope of what most of us can afford, or even what we need. And obviously, he's somebody you can hire for that too. But there are devices that are within financial constraints that we can get. And then there's obvious things to look out for. And maybe that's where we can start is, when somebody's in a home, what are the top, again, since we're going into solutions, not just the problems, but what do you see most often, and what are things people can do right now in their home without even spending much or any money? What can they go fix right now? What are the problems with everybody's house to reduce these issues? So
there are 4 types of EMFs in the building biology profession that we recognize. Magnetic fields from house wiring and overhead power lines, electric fields from house wiring, radio frequencies that would be from all the wireless devices, and then dirty electricity. So there are 4 sources of magnetic fields, outside power lines or underground power lines too, that can come in, and they come right through all building materials. So you can't easily shield magnetic fields, especially from something as large as the power line outside your building. They just pass right through the materials, and if you put some kind of shielding, they'll just bend around the edges and repropagate. So it's very difficult to stop them. That's the first. Then the other 3 sources of magnetic fields are wiring errors. So when you turn on certain loads, like you turn on the lights at the switch at the door, and the lights come on, but there's a field that you can measure with a Gauss meter. So here's one Gauss meter. We'll talk about these later. Here's another Gauss meter. Here's another kind. This is the more professional grade that we use. But you can measure magnetic fields, and also with the Trifield meter here.
Real quick, just to put a pause. So when you were talking about electric fields coming in from outside, are those bed shields, like those kind of things that shield the bed, are those any good against it, or are you just...
the canopies.
Like some kind of, some of those EMF canopies that are...
Okay, so the canopies that people who are sensitive to radio frequency EMFs put around their bed are only designed to block radio frequencies.
Okay, so they won't do anything.
Or the Y-Shield paint or Cooper Coat paint or the Air Pure paint, which is based on carbon, copper, and nickel, respectively. Those paints, which are primers. And you put them underneath paint, and then you put.
But that's just blocking the RF
They're non-toxic.
stuff.
Those paints and some of the fabrics, like perhaps this argent mesh here, can also be grounded, and they'll also block electric fields.
Oh, that's right. That's what you had us do in our bedroom.
But not
That's
magnetic
right.
fields.
Right.
They
right,
don't
right.
block magnetic fields, and not all of the materials are groundable. So you can have Swiss Shield, for instance, which is they all have silver or some other kind of thread that's inside of these, that's woven into this. This happens. Argent mesh happens to have polyester and silver woven together, but Naturel and Swiss Shield, Daylight, these are all cotton based, meaning that they have silver threads with cotton around them. And when the cotton surrounds that silver thread and you put a clamp on it, you're not able to grab, you can't get to the silver thread because it's encased in cotton. So those are not shieldable or groundable. They're not groundable. So you can't use them to shield electric fields.
Do you still send people to nomoreemf.com? Is that a good place for this stuff that you're talking about?
I saw that, sir, and I don't know that website. Less EMF.
That's it. Less EMF.
Yeah.
Right.
And Safe Living Technologies are the two primary vendors that I work with, and I know them all very well there. Less EMF, Emil de Toffel and his crew are in upstate New York, and then Safe Living Technologies is the other company, and that's Rob Metzinger and his crew in outside of Toronto. But he sells to people in the United States as well as in Canada. SLT.co is his website for his company, Safe Living Technologies. So those are the two companies that I work with. So when you want to measure EMFs, then you need a meter, and you need a separate meter for each one of them, or there are some combination meters. They differ in terms of their sensitivity, as I said in the last segment. The Trifield Meter, which is a very popular meter, it's tri-field. It measures 3 fields: magnetic fields, electric fields, and radio frequencies. It's accurate, or let me say it's sensitive in the magnetic field, for magnetic field EMFs. It tends to, the frequency weighted model, which is what this is, they're both model 100XE, tends to overstate the case for higher harmonics in terms of the magnetic field component of the dirty electricity. And the flat response model does not. And so that needle will be lower and more in keeping with a digital Gauss meter. And you know you have a flat response because it says flat response right at the bottom there. This is about $150.
Okay, yeah.
But
it's in the range.
And it is a triple axis meter. So what does that mean? It means that no matter how you orient the meter, you get the same reading. See, this is a triple axis meter because it has coils that are in the x-axis, the y-axis, and the z-axis. It has 3 little coils in there. So does this. And you know that because you see this little diagram here and here. And it says in the manual, or in the catalog, that these are triple axis Gauss meters. So it doesn't matter which. So if I turn this on, and we see the number is, wow, 2.5. It doesn't matter which way we orient this.
Should we have him get a little close cam on this, too?
Well, all right, so we
so you can show.
I don't know why we have this, but we do.
This is Hugo, everybody, coming into frame.
So these 2 meters are showing about 2.5 milligauss, where we're sitting right here. All right. So this is in the magnetic field mode, and it's measuring milligauss, not nanotesla. And it's 2.4 milligauss, and this is showing the same thing. But the point is, no matter how I orient these, if I keep it in the same location, it'll be the same number.
And are these anything you recommend people get? Or are they within range
well,
of
this is almost
pricing range?
this is almost $2,000.
Okay, so these are your toys. These are the toys.
Well,
yeah.
Gigahertz Solutions in Germany designed this meter with building biologists.
Okay.
For building biologists. Anybody can buy them, and this measures both magnetic and electric fields, and it's, I don't know, $1,700,
So what's this telling us right now? What kind of harm are we if we were to sit here forever?
we've got 2 milligauss of magnetic field exposure in this location here. I'm not sure where it's coming from, and the way we can tell is we move the meter. So we move it up, and it's about the same. And we move it this way, and it's less.
Goes less.
See? Now we move it this way, and it's less.
Stays about the same?
Well, here's the problem.
So what are we...
It's changed. It's no longer it's no longer 3 milligauss. It's 0.9. So the field has changed. So you told me that, I'm remembering from 3 years ago, there's power lines near here. Right?
Yeah, right across the alley from because if you go on the balcony, you can look at the power lines on these.
So
those are coming in.
All right. Well, then we're at the sort of edge of that field, and so sometimes the field increases because of unbalanced loads, net current, because of if it's overhead power lines, you'll get magnetic fields from overhead power lines because of separation of the conductors. Because current goes down the hot wire, and the electrons flow in a clockwise direction as you look from behind. That's called the right-hand rule. So, and the current flows to the destination, to the electric load, and then comes back on the neutral. So you turn your palm over because now the current's coming towards you, and now the current is going the electrons are going counterclockwise. So you have these two fields in terms of electrons. They all go in one direction. That's just the nature of a magnetic field. And you have these two conductors. You have a hot going out to the load, and then a neutral coming back, and they're side by side, pointing. The current's going in opposite directions. So the magnetic field is going clockwise around the one, counterclockwise around the other. You bring those two wires together, like in a circuit, and they superimpose and they cancel, and so you have no magnetic fields in the room. But what if you have a wiring error? What if you have two circuits coming into the same junction box, and the guy's not paying attention to the code, and he takes the white wires, which are bringing the current back from each load, and he wire nuts them together. And now that current on one load has two ways to get back to the panel, the way it should be, 100%. But say 75% on that and 25% going this way. That's how you get a magnetic field in your house.
Is there, to put it back into practicality, is there something kind of an affordable device that people can get to measure that, or how would they know?
So one way,
and by the way, it's okay to say if there are certain things that maybe the devices ascend the private consumer range that maybe they need to just call an expert in. But if there's toys that are within reason that they can.
I encourage people to get meters. I think every electric.
You do. I love it. I love it.
I do.
You give away your job to others.
No.
I love it. That's what I do.
Well, I'm open source about all this stuff. I mean, if you go to my website, it is literally like an encyclopedia. I've been writing, adding more to it. In fact, if I keep getting the same question multiple times over the span of a month or two, and instead of writing a long answer to people,
so let me reel you back in. So
I put an article.
Sure.
I have, since I last saw you, I have all these new articles on my website: EMFs in cars, healthy lighting choices, rooftop antennas for. I have EMFs. Let's see, what else do I have there? Baby monitors. I have an interesting article on there on EMF networks and your health, and we talked about this in the previous hour. Where people are picking up these networks, but the levels are low in their house. So anyway, so there's a lot of information there. So when it comes to getting your own meters, I want people to do that because.
So back to that specific question, which meter would they detect for a wiring inadequacy in their house? So because we have four sources of magnetic fields: power lines outside, wiring errors, current on water pipes, and or TV cable, grounding paths, and then point sources.
Point sources are like motors and transformers, and those drop off very quickly within 6 inches or a foot or two.
Like the magnetic energy off an LCD screen.
Which is only 6 inches,
right.
but the old cathode ray tube television sets and
would
computer monitors
the room.
4 feet.
yeah.
But the motor in the back of your refrigerator has a magnetic field that goes out. Maybe it drops off exponentially. So the biggest drop is within the first foot, and then it tapers off the next foot or two. So by 3 feet, it's gone. You don't want to have your head in that first 1 or 2 feet. You don't want to sit or sleep on the other side of the wall from the back of a refrigerator or freezer. Oh, excuse me. Also, you don't want to have a bed or a chair or a couch close to a breaker panel or the back of a cathode ray tube television set for the reasons we just mentioned.
If anybody's got those anymore. If you're at your grandma's house, don't sleep on the other side of that wall.
Or computer monitor. But
your
those
great grandmother's house.
But also around your computer at your desk, you can have an uninterrupted power supply, UPS, big battery backup thing. The magnetic field is huge around that thing, and also the subwoofer.
I remember you measured. That was one of the big things we did in the house. Was that all of my computers they've got all those stupid block brick
another
plugs,
thing. The little transformers,
and there would be like a giant power supply underneath, which everybody has, by the way, at home. They have a giant power supply with all the things getting plugged into it, and that's sitting right there on the floor next to you instead of further back behind, at least a couple feet away from you, because again, that magnetic energy drops relatively quickly.
So now that we reviewed the sources of magnetic fields, then we teach our students to do the following, and clients, when they have a Gauss meter, and you measure magnetic fields with a Gauss meter, Gauss, because that's the man's name, Dr. Gauss, back in the 1800s, who discovered magnetic fields. So 1 Gauss is named after him. That's a unit of measurement. And a milligauss is a thousandth of 1 Gauss, and that's the unit that we use. We say it's best to be below 1 milligauss in general.
In a room,
yes, and below half a milligauss or so at night when you sleep, ideally. So this is called the Gauss Master. It's well worn from holding it, and all the writing on the back has been worn off just from my holding it with my fingers. But basically, this only has one button, and you turn it on that way. Okay.
You got to love a device that you can't screw up. It's got an on
and there's no off button. It just goes off by itself after 10 minutes or so. And so this tells us, this is a single-axis Gauss meter, but it's only $35 from Less EMF and Safe Living Technologies, I think, may sell it, and others. But this is a single axis Gauss meter, so there's one axis that will give us the highest number.
As opposed to your more robust.
Yes.
Right.
The other ones that I have on the table here, this one, which is a digital triple axis Gauss meter, it does the computing for you because there's a formula. So this has 3 coils in it. This only has 1. And there are some combination meters on the market. Cornet has one, the ED78S or the ED88T are both single axis Gauss meters. Okay, but they also have a radio frequency detector in them. And then the 88T has an electric field.
So when you're using this one, all it really means is you have to kind of keep moving it around to make sure you're getting an accurate
when you
reading.
go around a room, if you see that it goes up, you have to do the let's say that it goes along like this. This would be the x-axis, the y-axis, and the z-axis.
You have to make sure you're moving in all those to.
That's right. Just like because you could have a low number one way and even another, and only a high number. This way, for instance.
So you said a safe reading on that. You said if somebody like in a sleeping room, like a room where you would sleep in.
Ideally,
what would be an ideal
below half a milligauss. Now this goes from 0 to 10, and when you hold this in, you're now in mode 2, which is 0 to 1, and these are tenths of a milligauss.
Okay, got it.
So there's a little misunderstanding in the way you might interpret what they say on the back. Because people say, I've got EMFs all over my house. I say, what meter are you using? Oh, the Dr. Gauss or the Gauss Master.
And I push the button and hold it.
And I say, are you holding your finger? Oh, yeah. I said, well, you're not supposed to do that. Only if you want to know tenths of a milligauss. They say, but it says on the back to hold it in. I said, no, you misread what they said on the back.
Right.
So anyway, this is a good way to to get a sense, to do a survey in your house.
Well, this is great. So if somebody's scanning their room and they end up with a high reading on these and they want to mitigate it, what do they normally look for?
We do the same thing when we do our professional evaluations. You have to figure out what the source is. This is what we teach our students and our clients. So when I'm sitting at the table in the beginning of the day, going over for an hour what EMFs are, where they come from, how they affect your health, and what we do about them, and then I turn on my meter, and let's say I turn it on, and it is like 3 milligauss, or even 1.3, which is right here. And a moment ago, it was up to 2.5 to 3 milligauss. That's not good. That's higher than I want it to be. So I need, and you're asking me to tell you what the source is and how to get rid of it. As a practitioner,
you would walk around and find, and so what we try and locate 0 point the source.
Yes, we tell our students and our clients, you have to move this in different directions. Well, first of all, you might turn it on and just leave it there. And this one happens to have clicking, which we can adjust the volume for. But
yeah, it sounds really. I love it. It sounds like something really bad is happening and radiation.
Well, yeah, exactly.
We're about to all be like superheroes in here now.
I can make that louder or softer. But the point is, you just sit here and you watch and you notice, oh, that's fluctuating. Well, that tells me right off the bat, without moving this, it could be one of two things. It could be a power line coming in to the house from outside, or it could be current coming up from, it could be magnetic fields coming up from the floor with current on a water pipe underneath, for instance.
Okay.
Now, the difference between those two is...
Because it is changing, so that probably gives you a little clue as to which it was.
As opposed to a wiring error, which is rock steady.
And also remember, in this room, because of your coaching, we have shielded carpet underneath the carpet, and then it's grounded into the wall. Is that protecting any of this?
Not magnetic fields.
Not the magnetics,
Only the electric
Only
fields.
The electrical fields, okay.
So if there's a wiring error going on here, if that's what we're picking up, it wouldn't fluctuate. It's rock steady. Unless you turn on another load, then it changes, up or down.
Right.
But if it's fluctuating like that, then it's either current on a grounding path or power line. Now, if the magnetic field that we're getting sitting here at the table is from current on a water pipe beneath us, from outside in the front yard, from the water main, which is a path for some of the return current to get back to the transformer for the neighborhood.
That was your guess a couple of years ago, yeah.
Yes. Then that number will get higher as we go down towards the floor and sweep back and forth and say, oh, here it is, and you follow it. It's like a line. But if in
our case, I think it was as you went towards the wall where the street is, the street into our unit here, into our complex.
Because we're up on the second floor here?
We're on the second floor, yeah. And then that was, as we got closer to it, I remember you saying it was much more potent as you were heading towards the street, and then it would drop sharply coming back.
Yeah, but we shouldn't be getting magnetic fields coming up from the pavement out there 2 flights up. That means that there's some serious...
grounding issues?
We're all in favor of grounding, and grounding is necessary, and there's a reason
grounding issues, yeah.
But we don't want current on the grounding paths.
Gotcha.
That's the point. So, and so...
So what would some solutions be if you found...
Well, there is mitigation for that, and that is the hiring a plumber to put in what's called a dielectric union, which is either a plumbing fitting, and I have one in my box. I won't take the time to get it out now, but it's a metal fitting with a ring of plastic in it. And they cut out a piece of copper about 3 inches and then put this in there and solder it in. And then it's a brake for the for current.
It doesn't conduct beyond that.
Right.
Point.
It's not like current comes to here and stops and you can measure it with a clamp meter like this one here. This is a big clamp meter which you can put around a hose, around a pipe, and then would plug this into a multimeter like this. Okay, so you would plug this into the multimeter, and then we would...
Are you Egon Spengler right now? I think we're picking up on...
Oh, okay. So this is
ghosts.
This is how you would measure around a big pipe. And then I have another meter here, which is $35 on Amazon, and this is the triplet 9200A, 9200 capital A, by TRIP.
This is a lightweight version of this nice
LATT. Yes. And this is for a circuit or a smaller pipe. And this gives you so these are clamp meters. These
Okay.
measure around pipes and wires that give you the net current.
Now, if somebody has plumbing expertise on their own, they could obviously do this.
They
could do this
could.
piece.
But there's some grounding issues that we have to discuss with them.
Okay.
Because you want to make sure that the current is going properly back to the electric utility on the neutral wire of the service cable that's overhead coming into your house.
Right.
Or underground into your house. It's called the service drop or the service lateral, depending on what's overhead or underground. And that's 3 wires on a typical house. 2 wires coming in, 1 wire going out. The hots come in, the neutral goes back. Whatever current you have coming in on the hots, that's the only way that current gets into your house. But the current that goes back has multiple ways it could go back. It should
right, I remember this
it should
conversation
all
now,
it should
yeah.
all be on the neutral wire up there. But if it's not all up there, if like 85%'s up there and 15% is going on another path, then remember I told you that if you have a certain amount of current going on a wire, you'll have a field commensurate with that. Well, what if the field around because you have 8 amps coming in,
you even
is
took
this big?
electrical wires and started separating them and getting a different, as the wires of a plug are pulled apart. Sometimes you see those 2 wires together and you can kind of split them in the middle. You were showing
Yes.
that
I have that in my box down there.
accentuated as you open them up.
Yeah, so you want the wires to be together, but in this case, we have so we have the current coming in and the current going out. So if you have 8 amps coming in and 7 going back, and I put this clamp around those 3 wires, and I get up on a ladder or from a balcony and I can reach down and carefully clamp around those wires, and I don't get 0. I should get close to 0 on this. So 8 in, 8 out. That produces no magnetic fields in the yard or through the house because it's even. But if there's 8 coming in and 7 going back, then we've got a difference of 1. So where's that extra 1 amp going out of the house? It's going under the house, in the crawl space or basement, on the grounding conductor that's grounded to the water pipe at the front of the house, which goes to the city water main under your front yard, because that's a grounding path for lightning to get into the earth. That's why it's there. That's why this grounding path is there. Not only do you have an earth rod going into the ground underneath the breaker panel, you have that's a way for lightning to get into the earth, that 8-foot driven rod that they drive into the earth. But also 30 feet of copper wire underneath your yard, and that is another way to get lightning into the earth. But the problem is that pipe is connected to a water main that every other house on the street is also tied to, and so you have a path now for current. Some of it. It's not a lot because the resistance is much higher than the neutral wire of this service cable. But say 10-15% will go that way. And it goes back to the transformer through the neighbor's house. And some of their current will go through your house. So these are the tools that we use. We use clamps. Here's a small version of that. And then we use Gauss meters. And this is how we start off. We start off with the Gauss meters. So again, the Gauss Master, the Trifield Meter. This is $35. Yeah. This is $150. This is $270 or $320, depending on which version you get. This is a digital 3-axis Gauss meter. Gigahertz Solutions, by the way, makes much more affordable versions of this. A single-axis Gauss meter and a single-axis electric field meter for a few $100s from Safe Living Technologies. So that's a good investment as well. They're all between less than $100 to a few $100s. If you want to get a triple-axis Gauss meter, which I recommend, because then it doesn't matter which way you hold this, you always get the same number no matter which way you hold it. Right. Because it's computing it for you. It has 3 different coils in here, and it's computing it for you. But you're going to have to spend a minimum of
what are some other common things you run into in houses?
$200 or more for that.
What are some other common things? So we were even maybe in this room, even as an example.
Well, okay. All right. So every house has electric fields. Yeah. Every bedroom has electric fields. Even if you have metal clad wiring, like in Chicago and New York and some of the older houses in Southern California, which they used the metal clad wiring, which is this ribbed kind. I have a piece in the box there, but it's basically the spiral kind. You see it in your garage, in your basement, and it protects. It's flexible, or they have rigid pipe, either one, and it's called metal conduit or metal clad wiring, either rigid or flexible. That shields the electric field. And it also protects the wiring from a nail or from rodents, because the plastic wiring in walls, they'll chew on that.
Oh yeah, and that too, yeah.
And it shears in an earthquake. So that's why they went to the metal wiring, especially here in Orange County and in Los Angeles, back in the 60s and 70s.
Although I think you told us that we had kind of the plastic shielded wiring in this particular place.
Because this building, this condo, was built more like the 80s or
probably
90s.
Yeah.
See, they stopped using the metal clad wiring in the 70s.
Okay.
So 80s, 90s, 2000s, it's all plastic. Mm-hmm. And throughout the rest of the country, where they don't have earthquakes, it's all plastic since the 40s and 50s. What prevents magnetic fields in house wiring and circuits is avoiding wiring errors, because the magnetic field will go right through the metal cladding.
Oh, got it. So it doesn't matter.
Doesn't matter.
Okay.
Metal cladding or twisting of your Romex, your plastic wiring in walls, that doesn't stop the magnetic fields. I mean, yes, if you put a Gauss meter right on top of it,
fields.
it will reduce it from 3 inches to 1 inch. That's literally the only thing with twisting, and you can break it because some guys would get really, they'd put the wiring on a drill and fire that drill and go, and they'd really spin it up and twist it really tightly, and it would break the conductors. So
let's go back to more solutions in the house too. Like what's everybody running into in their house? We know they have Wi-Fi.
Now,
people sleep with their Wi-Fi in their room.
Yeah. Well,
people sleep with their cell phone next to their bed. People sleep. Do you know? What are some of the things you see in common? Like, give me the top 10 list of stuff you see that people can correct.
Well, I know what people want me to say is smart meters, Wi-Fi, and it's all there, and I'll talk about that in a moment. But there's electric fields, there's magnetic fields. Nobody talks about that, and it's prevalent, and it can actually be worse than just
the frequency.
So first of all, most homes.
I'm getting you now. I get you. I see where you're going with this.
No, and it's important. I've been harping on this, Saren, for my whole career, because so many people every day they call me up and they know what they read on the internet.
Yeah.
And they're really afraid of the EMFs, or they're concerned. They want some advice, and they either hire me or they're calling from out of state, and we need to talk. And I guide them to somebody locally there, or they can call me. I do long distance consultations by phone, and I say, you get some meters. You get meters, and then you give me the readings, and I'll guide you on how to do that. So then, and they give me photographs, and I'll work with their electrician if we need to repair the wiring errors. So I do this consultation long distance. If there's nobody from my profession in that place.
That's actually a great resource for people. So if they're at home, you can get some of these devices. We'll talk more about some of the ones you can pick up, and then they can call you, work with you, and then you can give them the advice, give them the readings in which rooms are.
So we'll get to the radio frequencies in a moment. But everybody misses this stuff. Right.
I totally get it now.
So thank you.
Yeah.
And it's important, because not every house has magnetic fields. 50% of 1/3 of the homes in America have wiring errors, so that when you turn lights on, you get magnetic fields.
Oh yeah, okay. I remember that. We turned stuff on, and that thing over my head was like, whoa.
and if you have wiring errors, then
you were surprised I wasn't glowing, as I recall.
Then you need an electrician to come. I come back with an electrician to fix those. I just spent the last day and a half doing that in this client's house. And when you do, the magnetic fields drop. I have several clients who have cancer, and their dogs cancer from the wiring errors. I'm sure of it. I have colleagues who say the same thing. It's a small sample.
Actually, that's a great. Is there a direct scientific link yet, even from other countries, showing cancer specifically related to magnetic fields? Yes. We know this.
Many studies.
You have some published on your site?
Yes. Well, on my website, I have a link, articles on EMFs.
Okay. On
that page, which is a portal page, I have 5 articles that I've written. The first is an introduction to EMFs, which goes over a lot of the stuff that we've been talking about here in the last time. Then another article for each one of the 4 types of EMFs. So that's 5 articles. If you go to the article on magnetic fields, then I talk about the 4 sources: power lines, wiring errors, current on grounding paths, water pipes, metal water pipes under the front yard, TV cables. And the last one is point sources, transformers, and motors. So I talk about these magnetic fields and how it's a violation of national code, but the code inspectors don't look for these things. So, and then I also have in there links to at least 6 different websites, each of which has multiple studies to show the link between magnetic fields over 1 or 2 milligauss and illness. Not always cancer, but illness. So that research is there. Not all of it has been done in the United States, but I have links that they give that.
Perfect.
So magnetic fields are not the most common EMF. They're the least common of the 4, actually, but they're the most harmful if they're present.
Got it. Okay.
And 1/3 of the homes in America, in general, have wiring errors. So you can have wiring errors and not know it. And I'll tell you, magnetic fields wear you down. Electric fields wear you out. I talked about that in the other hour, how electric fields occur and what they do is this field comes out 6 feet and then collapses and comes out and collapses. And I talked about the fact that there are charged particles in every cell that are alternately attracted and repulsed. What I didn't talk about was the net effect of that. The net effect is 2 things. Your melatonin is not released like it should be in the middle of the night. And the second thing is you don't drop into stage 4. I did talk about that. You don't drop into stage 4, so you wake up tired. That's electric fields, okay? 100% of houses have that, even if you have metal wiring. Because if you have metal wiring, you're still plugging in a plastic cord. So when you turn that light off, it's like a garden hose. When you open the spigot, 80 pounds of pressure goes to the end of that hose and fills it up and stops at the nozzle because you haven't squeezed it yet. That's like turning on the breaker and 120 volts goes to the outlet and you plug in a lamp cord but don't turn it on yet. That's like adding another length of hose with a nozzle.
Right. I remember this is one thing we did was cleared my room out of anything
electric fields.
Plugged in. If you have a lamp next to the bed, even if it's just plugged in, there's stuff going through the wire.
Yeah, but the solution is not to unplug
Well,
that.
it's to turn the breaker off.
If you have plastic wiring.
Yeah.
No, if you have metal wiring, like in the house I live in, which was built in the 50s up in Los Angeles, there's metal wiring in the wall. So, because that was like I said, that was the standard, not the code, but it was what a lot of guys did back then. And so we don't have to turn off any breaker. We have one lamp and we have a little plug-in switch. It's in my box here, but it's $5 at the hardware store. You plug it into an outlet, it has 2 prongs, or you get a 3-prong one, and then it has a switch on top, and then you plug your lamp into that. We leave the light on up here. And so when we want the light out, we flip it off at the wall, if we can reach it. And then the cord goes dead, and there's no electric field from the wall because we have metal wiring, but that's pretty unique. If you live in Chicago or New York, there's no electric fields ever from your walls because by code, there's no plastic wiring in any of the boroughs of New York. It's all metal. Has been for decades, and that's not going to change. And all the buildings in Chicago, in all the Cook County and all the surrounding counties, it's all metal in Chicago and Beverly Hills and a few other places. Although they just changed it to plastic this last year. But the point is, if you have metal wiring, you have no electric fields day or night from your walls. But all the cords that are plugged in, even an extension cord, even your phone charging cord, even at low voltage, it's still emitting a huge electric field all night long, even if you unplug the lamp or turn off the lamp or unplug your phone. That cord within 6 feet of your body is emitting this electric field, and it's not going to give you a good night's sleep. So that wears you out. It robs you of a good night's sleep. Electric fields wear you out, and they rob you of a good night's sleep. You don't get the deep... But
don't fall asleep with anything plugged in. You guys with Rife machines that are treating all night, not the way to go. Guys sleeping on beamers and whatever else,
not a good idea.
Not a good idea.
Because,
in general,
because they're two-pronged. Yeah.
Even if the room is protected and safe, if you're running a big power cord from somewhere else, because we've done that trying to... I have an air ionizer, which is amazing. This eliminates like the mucus buildup and some of those things. It was the first time I ever woke up with clear sinuses. But yeah, we still, have to plug that in, but we're going to have to move that farther away after this conversation. We're going to move that even farther down the
distance
hall.
makes a difference.
Yeah.
Distance is your friend when it comes to magnetic fields, like point sources or a wiring error. If you're in an apartment and you've got a hot spot from a wiring error from from circuits or current on water pipes that you don't have control over because they're in the walls, then you get a Gauss meter, get your own Gauss meter, and then go around your apartment and you find the hot spots and you just move away from them. And you see, and you'll notice that they may fluctuate or not, but you just stay away from them. That's what you do in an apartment. In order to help people get a good night's sleep, what we need to do as building biologists and what clients need to do for themselves and for the family, for the kids, is to create a zone 6 or 8 feet. That's the magic distance for electric fields. Anything beyond 6 to 8 feet doesn't matter. If your room is big enough, you can have it over there.
Right.
But the problem is that circuit that's in the wall that goes around the whole room to like 6 different outlets, it's all the same circuit. And you need to shut it off here because the field that comes out, even with nothing plugged in. That's the point I'm trying to make. So when you squeeze that nozzle...
Which is what we do. We flip the breaker. Yeah.
When you squeeze that nozzle, the water shoots out and you feel the kick because of the 80 pounds of pressure in your hand. When you let go of that nozzle and the water stops, you still feel the kick in your hand because the pressure's there right up to your hand in the hose. In the same way, when you turn off that light, there's still 120 volts of pressure up to the switch coming out of that plastic cord and from the plastic wiring in the wall, which is called Romex. 6 feet. 6 feet, okay, in all directions. And you're laying in that, and it's having an effect. So you're getting an electric field from behind your head, from your left side because of the cord here, from under your legs because of another circuit that's over here. Here's another thing plugged in. Your clock is over here. You're getting it coming at you from all different directions. You have this agitating influence all night long. You need to shut off that breaker, and then the whole thing stops. But then people say, but I need my machine. I need my TiVo. I need my CPAP machine. I need my air purifier. I need my sound machine. You need battery for all that stuff, or we have an electrician put in an outlet, a dedicated outlet in the metal cladding, and then we have to shield the cord. We have to get the CPAP machine more than 5-6 feet away from the body with the plastic hose.
Okay, so there are good solutions.
Yeah, and people.
And that's a good question. Is so if devices run on batteries,
no problem.
No problem.
Well,
there's a small magnetic field off of the battery or something of that nature.
I'm hesitating because the super electrically sensitive can't even have a battery in their hand. I mean, that's how sensitive these individuals are, and I respect that. But that's
in general,
So battery operated clocks are good. So it's tricky, Siren, because my goal is I have to get that electric field level down where people sleep.
Right.
Now, if you're in an apartment or a condo, you've got neighbors, and you could have, and you either have metal clad wiring or plastic wiring, depending on the construction of the building. If it's steel and glass, it's all metal, even in anywhere in the country, like condos. But if it's a wood frame apartment or condo building, then they can use the plastic. And so if you have plastic, you've got 2 people. If this is your bedroom and here's your neighbor's bedroom, a completely different unit, there's 2 wires in that wall. One for your outlets controlled by your breaker subpanel, and the other circuit that's in that same wall with outlets on this side, which is controlled by their subpanel, which you have no control over, and the field comes out both sides of the wall, 360 degrees, 6 to 8 feet in all directions. So you have, even if you shut off yours, you still have a field that comes out.
And that's why what you advised in our bedroom,
you got to put the bed over here.
Yeah, that we move the bed to a wall that's not shared to a wall inside of our own condo. Then we can flip that off because we can't control.
Then you can shut off the breaker for that bedroom
and have the benefits of it.
So we shut off all the breakers, and then we go around and we test with So this is This is called a body voltage meter, and this is something that people can buy for less than $100, ready-made by Less EMF, or Safe Living Technologies has their own version, which is a little bit more expensive. And let's see, where is the other? Here it is. So it's, or you can put this together yourself. I have a page. It's in the EMF Meters and Instruments article that I wrote, which talks about all of this stuff. Recommended meters, magnetic fields, electric fields, radio frequencies during electricity. And in the electric field section, which is the second section, I have a handout with parts. Radio Shack, this is the most expensive part. It's $45. And then you get your own cord. This is a special thing, but even this, you get 2 of these with these leads here, and they both have this pointy end here, and you put the second one in here, and you just hold it like that, that's enough. And then this one here goes into one of these, which is from Radio Shack. It's just an alligator clip here with which I cut the plastic away from, and at the other end, it can take this. So that goes in here, and then you get some more of these, and here's some speaker wire that I got. Actually, that's what this is. This is just individual speaker wire. It comes two, and I stripped it apart.
Device he's talking about right
This
here.
is the and this is Radio Shack,
which is not in business anymore. I see, right?
No, they're online. You can still get their stuff online. They're closing their stores, or many of them. So then this clips to this, and this is something you get from Less EMF. It's called it's a patch cord, and at one end you have just a ground plug, or it has all three, but the two blades are not connected to any wire because there's only one wire coming out of it, which is only connected to the ground. So this happens to be a plug to gator patch cord. They have other ones, plug to USB.
I have a bunch of those after you came in.
Yeah, plug to ring, but this is plug to gator, alligator. So then this goes into a grounded outlet, and you must verify that the ground is good with this, where the two yellow, this is the ground light. This has to be on and as bright as the middle one, because this means that the breaker's on. Even if the breaker's off, by the way, the ground is still connected. But anyway.
Right.
Okay. So then you plug this into the ground, and now the ground is your reference. And then this gets plugged into this, this patch cord here, which you plug into either, and this is all on my website. And it doesn't matter which way you have it, but you have to go into the common and then the volt side over here, not the amp side over there. Or actually, they're both amp and volt here. Anyway, for the Radio Shack, it's these two. It doesn't matter which way you do it. It could be either one. And then the other one of these goes in here, and you can hold on to the clip, the pointy thing, or you get something like this. And I described this in the protocol. You turn it to volts, and then it always goes to DC first, and you go to AC. And then now, if this were plugged in, we'd be reading the number of the millivolt exposure. So this is an antenna. The other end of this goes to a grounded outlet, so we're using Earth as our reference, as our 0 point. So this is an antenna, and it will pick up the electric fields in the room. But when you hold this in your hand, as long as it's touching your skin, then my whole body is the antenna, even my legs. So people say, well, let me check out over here, and they're moving the meter over there, or they're doing this.
Touching it, right.
And I say, just watch it, use your hand. This is, you can use your hand as a gauge. What I've actually done is inserted this piece that has from the speaker wires. This gives me the ability to have the client move around the room more and go farther away from the. So now we're actually plugged into an outlet, and so now this is picking up the electric fields in the room, which, if I'm not touching it, says 280 millivolts, which is a quarter of a volt. Now, but when I hold it, I'm now getting 1,300. That's very typical because we have a lot of cords plugged in around us.
Yeah.
Yes, and by the way, this is a way of
if you were to see the ground, it's like Indiana Jones full of snakes down here.
When you press this, some of these, when you get within a foot or so of a cord, this will beep. All right, but this, I'm now picking anything coming out 6 feet. We have cords here, we have cords there, these lights. So this is...
It's a mess.
There's a lot of electric fields here. And this is not an uncommon number, 1,000. So it's 1.3 volts.
This is not an uncommon number?
No, it's very common. 1.3 volts, which is 1,300 millivolts.
Okay.
So then you take that number,
we have like 50 extension cords, and if this number is normal, then you're all in trouble.
1,000 millivolts, which is 1 volt, is under the extreme column. So we have 4 columns here. This is for sleeping areas, building biology evaluation guidelines, and you get here by clicking on that same link on my website, createhealthyhomes.com, building biology evaluation guidelines. You get a page that says click here, and this is the actual PDF from the Germans, the German building biology profession, translated into English. This is page 1. Pages 2, 3, and 4 are for formaldehyde, chemical outgassing, mold, and such. But this is fields, waves, radiation for section A. Sections B and C are the other things. So A1 is electric fields. A2 is magnetic fields, A3 is radio frequencies. And dirty electricity actually is just...
So is this showing us, this, like people should get this because it'll show them some of the levels that are
exactly.
safe? Okay.
So our goal is to get our clients at least out of the severe and extreme columns, which you often see.
Right.
And into at least the slight column, if not the no concern column. And this is from the Germans. They're really stringent, so these numbers are really low. So for those of you who know this stuff, you want to be below 1 milligauss. And so here's a dividing line between the severe and extreme columns and the slight and no columns. So here's the line right here. So 1 milligauss of magnetic field exposure, 100 millivolts or 0.1 volt on this meter, or below 1.5 volts per meter on this meter for electric fields. And then, believe it or not, this guideline says below 10 microwatts per meter squared, which is exceedingly low relative to the radio frequencies, which is measured here. And the FCC says 10 million microwatts per meter squared is safe. So there's 6 orders of magnitude there. Okay, so...
Thank you, American government, for keeping us safe.
So we should turn to all the radio frequency.
The thing that gets all the big headlines.
Yes. So what are
but
the
I do appreciate you waiting heavily on the other stuff that's being missed.
Just to tie that up, to finish that off, many other websites talk about how to reduce radio frequency exposure, and I'll go into it now as well, our opinion about that. But nobody talks about the electric fields.
Right.
I can list on one hand the number of really competent EMF experts that I know in the United States who are not building biologists who know about electric fields. Literally half a dozen of them, and that's it. Nobody else seems to know about them, and yet it's the most common EMF that there is.
Well, thank you. That's huge.
It's in your bedroom, and you've got to get rid of it. And for anybody who's struggling with any health symptoms, if you can get your electric field levels down at night when you sleep, you're going to go a long way towards helping all the therapies.
So let's do this. To wrap that section up then.
So if you want to reduce the electric fields in most houses in America or Canada or worldwide, actually Europe doesn't have this problem because they have 240 volts and they don't have a neutral. It's a whole different situation in those parts of the world that have 240 volts. This is for 120 volts here in North America. By the way, there's no metal water pipe in France, at least. I guess in all of continental Europe. I have a French electrician who I know, and he comes to California, comes to Santa Monica every year for his vacation, and we always get together, have lunch, and he says we don't have these problems with current on the water pipes because we have plastic everywhere. Under the street, in the house, there's no metal water pipes there, no magnetic fields.
So let's all move to France.
So it's different in the United States and Canada than it is in Europe. I know you have people out of North America who are listening to this. Your systems will be different, and some of these things don't apply. But for anybody in North America, US or Canada or Mexico, Latin America, you're going to have this issue. So you need to reduce the electric fields where you sleep. And if you have plastic wiring in the walls, then just shut off the breakers, and not just for the circuit that goes to the bedroom, but also you have to measure, because you could have 1 or 2 other circuits going through this 6-foot bubble around your body in all directions. If you're laying on your back, it's like a dome, 6 foot like that, and going beneath you, and 6 feet out from your head into the next room, and 6 feet out from your feet. It's like a cocoon, 6 to 8 feet in all directions. Right. Free of any live wires. Because remember, when the voltage is on, you're going to have electric fields, whether you have current or not.
Yep.
Even if you've shut off the light and there's no current, there's still voltage right up to the switch. And that voltage has this electric field that it comes out and collapses, but it's positive, negative in terms of the field polarity. And so there's this oscillating thing going on all night long. So that wears you out, robs you of a good night's sleep. Magnetic fields wear you down. They have a grinding influence on the immune system, and they compromise your immune system, your vitality, causes depression, and they will induce cancer. So do electric fields, and there's an 11-fold increase in cancer, according to some studies, when you have the two together. And since every bedroom has electric fields, not every bedroom has magnetic fields, but some do, then you really have a problem in that regard. Now, magnetic fields are a daytime problem and an evening problem because they come from wiring errors, but when you shut off the lights and shut off the loads,
they mitigate, they self.
There's no magnetic fields because there's no loads. Right.
That's interesting.
See, so when you go to sleep, there's generally not a magnetic field in most bedrooms, unless you happen to be over a grounding conductor that goes to the water pipe. Depends on whether you're on the first floor or second floor. I don't recommend people live or rent or buy condos or apartments on the first floor because you have these water pipes underneath in the ceiling of the garage, or basement, all carrying current on them. Be on upper floors to get away from that stuff. I've only seen one apartment building that didn't have current on the water pipes or wiring errors. Most of those buildings have wiring errors, and especially current on the grounding paths. So you just have to know where the hot spots are. It's tough. So anyway, and electric fields are a problem in the nighttime, but not in the daytime, unless you have an ungrounded computer or an ungrounded refrigerator. So it's kind of reversed. Now, radio frequencies are becoming a problem for everybody because we love the portability. We love the devices. You know, our cell phones are with us. We put them in all sorts of places. Women put them here. Men put them in their pockets.
Even our little this, which is a performer, is sort of a necessary evil too. I've always wondered how much, I have to wear a body pack and a wireless microphone. Fortunately, it's for a short burst of time, 90 minutes a show.
See, so these things...
But it's right on my body, you know what I mean? Like, I'd love to find if there's a shield, maybe I can put between it and my body.
You can get that from Less EMF or Safe Living Technologies or a number of other vendors. I'm sure you have others. You can put the websites there. There are other vendors that sell these
I'm going to end up wearing silver underwear, aren't I?
They sell that too.